Good morning, everyone. Today's topic is problems on inverse Laplace transforms derivatives. That is nothing but the derivatives of the given function's inverse Laplace transforms. Here we are taking some problems and how to solve the inverse Laplace transform by using of derivatives. Okay. The problem is find the inverse Laplace transform of find the inverse Laplace transforms of first one log of 1 plus 1 by s square. Second one log of s minus 1 by s plus 1. Third one log of s plus 3 by s plus 4. Second one s plus 1 by s minus 1. Okay. In this, how we can find out the inverse Laplace transforms of the given functions which are in log expressions. Okay, first of all, before of solving these problems, we recall the inverse Laplace transform derivatives, that is by the inverse Laplace transforms of derivative is, we know that L inverse of f bar of s is equal to small f of t, then L inverse of f power n of s, that is nth derivative of f bar of s is equal to minus 1 whole power n into t power n into f of t, or minus 1 whole power n into t power n into L inverse of f bar of s. This is the inverse Laplace transforms derivatives. If we take the first derivative, then we can substitute n equal to 1. We are taking second derivative means substitute n equal to 2. That is the thing. Here I am taking first problem and how we can solve the given problem's inverse Laplace transform. Okay. Here let f bar of s is equal to log of 1 plus 1 by s square. Okay. Next, taking LCM for this function, log of s square plus 1 by s square. Okay. We know the rule, log of a by b is equal to log a minus log b. By this formula, substitute in that, then f bar of s equal to log of s square plus 1 minus log s square. Okay. Now differentiating on both sides with respect to s, that is d by ds of f bar of s is equal to d by ds of log of s square plus 1 minus log s square. That is equal to log s derivative is 1 by s, that is 1 by s square plus 1. Again s square plus 1 derivative is 2s. The same way for the second function, 1 by s square into 2s. This is the formula. Okay. In this is nothing but f bar dash of s, that is the first derivative of the function. Now we can take both sides inverse Laplace transform, that is L inverse of f bar dash of s is equal to by the applying of linearity property to taking outside L inverse of S by S square plus 1s get cancelled, minus 2 L inverse of 1 by S. Okay, here substitute L inverse of F bar dash of S equal to minus 1 whole power 1 t power 1 L inverse F bar of S, that is equal to 2. We know the inverse Laplace transform properties. S by S square plus 1 is equal to cos t. This is the cos t minus 2 L inverse of 1 by S equal to 1. Then this minus is taking to minus t is taking to left side. L inverse of F bar of S is equal to minus 1 by t into 2 taking outside 2 cos t minus 1. Then multiply with negative. It is equal to 2 by t into 1 minus cos t. Okay? It is the inverse Laplace transform of F bar of S. Here L inverse of F bar of S is equal to, here L inverse of, what is F bar of S? Log of 1 plus 1 by S square. It is equal to 2 by t into 1 minus cos t. It is the inverse Laplace transform of given function. Okay. Here only thing is, if the given problem is in log, that is in log of a by b, then we can separate the terms log a minus log b. Next, taking the derivative of that given function and differentiating separately, then applying the f bar dash of s inverse Laplace transform is equal to minus 1 whole power 1 t power 1 L inverse of f bar of s, that is the by the inverse Laplace transform derivative of the function by using of inverse Laplace transforms derivative, then we are getting it is equal to minus 1 into t into L inverse of f bar of s. And the same way I am solving the second problem. Second one is, let f bar of s equal to log of s plus 1 by s minus 1. By using of log a by b, log a minus log b. Next, taking derivative on both sides, d by ds of f bar of s is equal to log of s plus 1 derivative is 1 by s plus 1, again s plus 1 derivative is 1, minus 1 by s minus 1, again s minus 1 derivative is 1. It is nothing but f bar dash of s is equal to 1 by s plus 1 minus 1 by s minus 1. Now taking inverse Laplace transform on both sides, L inverse of f bar dash of s is equal to, by using linearity property, L inverse of 1 by s plus 1 minus 1 by s minus 1. By using linearity property, we can write separately L inverse of 1 by s plus 1 minus L inverse of 1 by s minus 1. Here, in the place of inverse Laplace transform of f bar dash of s, by using the inverse Laplace transform of derivative, that is, if L inverse of f bar of s is equal to f of t, then L inverse of f bar n of s is equal to minus 1 whole power n p power n f of t. That is nothing but L inverse of f bar n of s is equal to minus 1 whole power n p power n L inverse of f bar of s. This is substitute here, then we are getting minus 1 whole power 1 into t power 1 into L inverse of f bar of s. Okay. By this, then that is minus t L inverse of f bar of s is equal to, we know that by using of inverse Laplace transforms property, it is equal to e power minus t. The second term is, here minus 1 is there, it is nothing but minus e power plus t. Then L inverse of f bar of s equal to, that is log of s plus 1 by s minus 1. It is equal to, this minus t is taking to right side, minus 1 by t into e power minus t minus e power t. Multiplying with negative, therefore L inverse of log of s plus 1 by s minus 1 is equal to e power t minus e power minus t by t. It is the solution. Okay. The third one is same like this only. Third one, let f bar of s is equal to log of s plus 3 by s plus 4. It is write separately by using of log property, that is log of s plus 3 minus log of s plus 4. Next, taking derivative on both sides, f bar dash of s is equal to, derivative of this is log of s plus 3 is 1 by s plus 3, again s plus 3 derivative is 1 minus log s derivative is 1 by s, that is 1 by s plus 4, again s plus 4 derivative is 1, is equal to 1 by s plus 3 minus 1 by s minus 4. Taking inverse on both sides, inverse Laplace transform, inverse L inverse of f bar dash of s is equal to L inverse of 1 by s plus 3 minus 1 by s minus 4. By using linearity property, L inverse of f bar dash of s is equal to L inverse of 1 by s plus 3 minus L inverse of 1 by s minus 4. By using the linear inverse Laplace transforms derivative, this L inverse of f bar dash of s can be written as minus 1 whole power 1 into t power 1 into L inverse f bar of s, that is equal to, by the inverse Laplace transforms property, 1 by s plus 3, here plus 3 means, then that is e power minus 3t minus e power minus 4 is nothing but plus 4t, e power 4t. This minus t is taking to left side, then L inverse of f bar of s is equal to minus 1 by t into e power minus 3t minus e power 4t. Multiply with negative and substitute f bar of s, then L inverse of log of s plus 3 by s minus 4, s plus 3 by s plus 4. plus 4. Plus 4 means here it is also minus 40. Okay. S plus 4 is equal to minus into minus plus, that is 1 by t into e power minus 4t minus e power minus 3t. It is the answer. Okay. Thank you.